Hello everyone, welcome to my channel. In this session we are going to see how to solve a given LPP using the simplex method. So the objective function is 5x1 plus 3x2, which is subjected to constraints 3x1 plus 5x2 less than or equal to 15, and then 5x1 plus 2x2 less than or equal to 10, right? And all the non-basic variables x1 and x2 are greater than or equal to 0. So as we can see that there are two inequality constraints in the given question. Now to convert that inequalities into equality constraints, we have to introduce a new variable called as slack variables, and then we will rewrite the entire equation in the augmented form. Okay, so now let us write the augmented form for the given question. So the objective function will be, so the augmented form z will be, or the objective function will be rewritten as z minus 5x1 minus 3x2 equal to 0, which is subjected to constraints 3x1 plus 5x2 plus s1 equal to 15, right? Similarly, the second constraint will be 5x1 plus 2x2 plus s2 equals to 10, and then x1 comma x2 comma s1 comma s2 all are greater than or equal to 0, right? Now after we convert this into the augmented form, we are going to solve this problem using the tableau simplex method. Okay, now let us do that. Since we have around 4 variables, right, in which 2 are non-basic variables and 2 are basic variables. So considering all this, we will draw the simplex table and we will solve the problem. Okay, so let us write the columnar headers for the given problem. So those are, I'll write the first one as x1, then we have x2, after that we have s1, s2, z, right hand side values, and finally the ratios. Okay, so now we are going to write the first constraint value. So as you can see in the question, it is 3x1 plus 5x2 rho. So in place of x1 you write 3, then you write 5. We have one slack variable 1, but we don't have the second slack variable 0, we don't have z0, and what is the RHS value? That is 15, right? Similarly for the second constraint, it is 5, and that we in the x2 we have 2, then we have 0 for s1, we have 1 for s2, 0 for z, and then we have 10, right? After that we have the z value. Okay, we have the z value. So z value we will write it as it is minus 5, and we have minus 3, then we have no slack variables, so s1 and s2 become 0, and z is 1, and RHS is also 0, right? Now what we need to do means, after we write on all the values in the table, we have to check in the last row which is the most negative value, or the highest negative value we have. So among minus 5 and minus 3, the highest negative value what we have is minus 5. So we will consider this entire column as the entering variable or the entering vector. Okay, right? So this will be the entering vector. Now what we need to do means, whatever the RHS value we have, right, so that we have to divide it with the entering vector column. So it will be 15 by 3, so that will give you the answer 5, and 10 by 5 will give you 2, right? This we are not going to find out. Okay, so among 5 and 2, the 2 is having the least value, and this will become the leaving vector. Now we need to encircle the entire row. Okay, so once we do that, the most intersecting value or the variable is 5 here, right? 5. So now what we need to do means, we have to make this 5 as 1, and rest 2, the upper and lower value, that is 3 and minus 5, we have to make it as 0, right? And to do that, what we need to do, we have to if I consider this as R1, this is R2, and this as R3. Okay, to make this 5 as 1, I need to divide R2 by 5, right? The row 2 divided by 5, if you do, then you will get the answer as 1 here. And for R1 and R3, what we need to do means we have to make that value 3 and minus 5 to 0. For that we have to write the formulas. Now I'll let you know how to write the formulas for that. Okay, so I will write it. I'll write down here, right? So R2 value will be R2 by 5. Okay, so what is the value for R1? What is the formula for R1? R1 will be R1 minus, okay, R1 minus 3. Okay, if it is, you can see that there is a positive 3, right? 3, so that we have to convert into negative 3. Okay, minus 3 into R2, and R3 value will be, since we have R3 minus, okay, since we have minus 5, so we have to make it as positive 5 plus 5 into R2. Okay, so if you have a positive number, make it negative. If you have a negative number, make it positive. So this is the formula. Based on these formulas, we are going to write down the values. Okay, so now what we write it, first we will fill up the second row, since we have to make it as 1. So 5 by 5 is 1 here. Okay, this will become 2 by 5. So anything divided by 5 is 0 divided by 5, right? So that is 0, and this becomes 1 by 5, and 0 by 5 is 0, and 10 by 5 becomes 2. So this is for the second row. Now using this formula R1, okay, we are going to write down the improved solutions for the first row. So that will become R1 minus 3 R2. What is the value of R1? That is 3. 3 minus 3 into, you take down this as an R2 value. Okay, don't take the upper value here, this as a R2 value. Now your R2 value is new, right? So we have to consider this row. Okay, now this is your R2, but your R1 value is still in the upper table, so this one, right? So if you do the R1 minus 3 R2, you will get the answer 0 here. Okay, so you can write down 0 here, and R1 minus R2, so it will be 5 minus 3 into 5 minus 3 into 2 by 5. So 5 minus 6 by 5. So that will give you, what is the answer? 5 minus 6 by 5. So you'll get it as 19 by 5. 19 by 5. Okay, and then the third column value will be 1. Okay, similarly the fourth will be minus 3 by 5. After that you'll get 0. Okay, and 15 minus 3 into 2. Okay, so that will give you 15 minus 6, that's 9. Similarly for the third row, we'll go R3 equal to R3 plus 5 R2. So this will become 0, right? And here it will be minus 1, and this will become 0, and here it is 1, then it is 1, and last you will get a 10. Okay, so this was the last row here, right? This was the last row here, and you can see there are one negative and the rest of the values are positive. So we are not reached the optimal solution. So among all these values, we have to consider only the negative value. So there is only one negative value, so I'll consider this as the entering variable, and I'm going to encircle the entire column. Okay, now we got the improved solution, and we got the RHS value, new values, right? 9, 2 and 10, among which we have to check for the ratios now. Okay, so 9 by 19 by 5, so it is like 45 by 19, right? So I'll write 45 by 19, and then I have 2 by 2 by 4, 5 to the, okay, 2 by 5. So that will give you 5. That will give you 5, right? And this we are now going to find out. So 45 by 19 will give you around 2.36, around 2.36 value will get. Okay, so out of this, the 2.3, that's the living vector. So among this 2.36 is having the least value, so this will be considered as the living vector. Okay, so now I'm going to encircle the entire row. That's the first row. Okay, so now what you need to do means you have to make this 19 by 5, which is the intersecting values, right? Intersecting values, you have to make this as 1, 2 by 5, and this minus 1 you have to make it as a 0. So now you have to find out the new formulas for that. Okay, to find out the new formulas, what will be the formula for R1 now? What is the formula for R1? R1 will become 5 by R1 will become 5 by 19 into R1, right? R1 will become R1 into 5 by 19. So if you multiply by 5 by 19, it will become 1. And what about the R2? First you write R2, okay, then it is positive, so I'll write negative, minus 2 by 5 into R1, correct? 2 by 5 into R1. Then R3 will be, first you write R3, okay, then it is negative number, minus 1, so you make it as plus. So that 1 into R1, so it is R1, R3 plus R1. Okay, now after doing that we have to write all the values. First we'll solve the first row because that is important. Okay, first we need to do, so this is always 0 and this becomes 1, and this 1 divided by 5 by 19, so this will also become 5 by 19, and this will become minus 3 by 19. Okay, and here it is 0, and 9 will become 45 by 19. Okay, similarly if you go for the second row, R2 minus 2 by 5 into R1, so that will give you the value 1, 0 minus 2 by 19. Okay, and this will become 5 by 19, and here it will be 0, and here it will be 20 by 19. Okay, then the last row, this is always 0, and this should be 0, and next will be 5 by 19. Okay, as per the formula you have to keep on evaluating it. Okay, 16 by 19, and this is 1, and finally this will be 235 by 19. Okay, and now you can see that all the values in the last row are all positive. That is the objective function values, right? These are all positive. So once we get the positive value, we have to stop the further iterations, and now it's time to find out the maximum value for the Z. Since the last value is Z, wherever you find 1, see this column is there, no, the last column, it is Z, so it should be like this. It should be, the rest of the numbers should be 0 wherever the column is pointing to 1, and what is there in the RHS value, that will be the value of Z. So in this case, what is the value of max Z here? So max Z value will be 235 by 19 at, what is the value of x1? So you can see that the first column, this one is for x1, right? x1, these are all x1 values, these are all x2 values, correct? No, so in the x1, see, where is 1? You should have 0 0 1 0 1 0. Okay, in that way the value should be, there should be 2 zeros and there should be only 1 ones. So where is 1 here? 1 is here, and that is pointing to the RHS value 20 by 19. Okay, so the x1 value will be 20 by 19, and x2 value will be, x2 also it's same case. No, in the second column you can see that there is only 1 once and the rest of the values are 0, but 1 is pointing to 45 by 19. So x2 value will be 45 by 19. Done, right? So now if you just substitute the value x1 equal to 20 by 19 and x2 equal to 45 by 19 in the given question, so as per the question, as you can see, max Z is equal to what? The value what we got in the max Z value here is 235 by 19, right? So we'll just compare 235 by 19, which is equal to 5 into what is the value of x1 we got now? 20 by 19. 5 into 20 by 19 plus 3 into 45 by 19, right? 3 into 45 by 19. So if this LHS is equal to RHS, then the given solution whatever the values you got for x1 and x2 will satisfy, and that's the optimal solution for the given problem. Okay, so if you do 5 into 20 by 19, okay, so you can easily understand that. So if you just multiply that, so 5 into 20 by 19, 100 by 19, okay, and then you just multiply 45 by 3 and divide by 19. So if you add these two values, you will get the answer as 235 by 19. So the LHS will be equal to RHS. That means the maxed value is 235 by 19 at x1 equal to 20 by 19 and x2 equal to 45 by 19. Okay, so I hope you understood the problem here. Okay, if you have any doubts regarding this, please do let me know in the comment section. Thank you.